Number system. Real numbers and their decimal expansions. Decimal expansion of number, terminating and non-terminating. Real numbers and their decimal expansions. Let us take 3 examples. 10 upon 3, 7 upon 8 and 1 upon 7. Pay special attention to the remainder and see if you can find any pattern. If you observed carefully, you should have noticed 3 things. 1. The remainders either become 0 after a certain stage or start repeating themselves. 2. The number of entries in the repeating string of remainder is less than the divisor. Example, in 1 upon 3, 9 repeating itself and remainder 1 is less than divisor 3. And third, if remainder repeat, then we get a repeating block of digits in the quotient. Example, for 1 upon 3, 3 repeats in the quotient, and for 1 upon 7, we get the repeating block 142857 in the quotient. From above examples, we have seen that when remainder becomes 0 after some steps, the decimal expansion of number terminates or ends. We call such decimal expansion terminating. When decimal expansion of number goes on and repeats block of digits in the quotient, we call such expansion is non-terminating recurring. While you walk on the number line, you come across a number like 3.142678 whose decimal expansion is terminating, or a number like 1.27 bar whose decimal expansion is non-terminating recurring. You can conclude that it is a rational number or not. Show that 3.142678 is a rational number. Now in answer, we have to express 3.142678 in the form of P upon Q. We can write 3.142678 as follows, which is in the form of P upon Q. Therefore, 3.142678 is a rational number. Show that 0.3333 is equal to 0.3 bar is rational number. We have to express 0.3333 in the form of P upon Q. Since we don't know what 0.3 bar is, let us call it X. And so, X is equal to 0.3333. Now, here the trick comes in. 10x is equal to 10 into bracket 0.3333 is equal to 3.3333. Now, 3.333 is equal to 3 plus 0.3333. Therefore, 10x is equal to 3 plus, instead of 0.333, we can write x. Now, 10x minus x is 9x is equal to 3. That is, x is equal to 1 upon 3. 0.333 is equal to 1 upon 3. Therefore, 0.333 can be written as 1 upon 3, which is in the form of P upon Q. From the above examples, let us summarize the results in the following form. The decimal expansion of a rational number is either terminating or non-terminating recurring. Moreover, a number whose decimal expansion is terminating or non-terminating recurring is rational. What about the decimal expansion of irrational numbers? The decimal expansion of an irrational number is non-terminating, non-recurring. Moreover, a number whose decimal expansion is non-terminating, non-recurring is irrational. We have seen the decimal expansion of root 2. What about the famous irrational pi? The decimal expansion of pi is... That is all in this topic. Let us learn about representing real numbers on the number line and operations on real numbers in our next topic.